The pilots flying B-52 bombers today weren't born when their aircraft rolled off the assembly line. Neither were their parents. In some cases, neither were their grandparents. This Cold War relic first took flight in 1952, back when Harry Truman sat in the Oval Office and television was still a novelty. 70 years later, it's still dropping bombs on America's enemies. And here's where it gets strange. The Pentagon plans to keep flying these ancient machines until 2050. Possibly longer. That's a century of continuous service from a single aircraft design. Nothing in military aviation history comes close. America has tried to replace the B-52 multiple times. The supersonic B-1 Lancer was supposed to make it obsolete. Didn't happen. The B-1 is now being retired while the B-52 keeps flying. The stealth B-2 Spirit was the next attempt. Too expensive. Only 21 were built. The newest B-21 Raider is entering production right now, and even it won't replace the aircraft your great-grandmother might remember. What makes a 70-year-old bomber irreplaceable? The answer involves nuclear standoffs that nearly ended civilization, engineering decisions made in a hotel room over a single weekend, a combat history stretching from Vietnam's jungles to Afghanistan's mountains, and one brutal truth about military aviation that took the Pentagon decades to accept. Some aircraft age out. Others refuse to die. In October 1948, a group of Boeing engineers checked into a hotel room in Dayton, Ohio. They had a weekend to save their company's biggest contract. The bomber design they'd been developing for 2 years was failing. Air Force officials had made it clear. Redesign the aircraft completely or lose everything. What happened over those 2 days changed military aviation forever. The engineers didn't sleep. They barely ate. They argued, calculated, sketched, and reimagined everything they thought they knew about bomber design. When they emerged on Monday morning, they carried a proposal for something entirely new. Swept wings instead of straight. 8 jet engines instead of propellers. An aircraft that existed nowhere except in their drawings and calculation. The Air Force approved it immediately. But why did America need such a radical new bomber in the first place? The answer goes back to the end of World War II. Hiroshima and Nagasaki had demonstrated nuclear weapons' terrifying power. Military planners understood that future conflicts would be decided by whoever could deliver atomic bombs to enemy territory first. The B-29 Stratofortress that dropped those first atomic weapons was already becoming useless for this mission. It flew too slow and too low. It couldn't reach Soviet cities from American bases without multiple vulnerable refueling stops. The aircraft that ended one war couldn't fight the next one. The Air Force needed something revolutionary. A bomber that could fly from the United States to Moscow and back without landing. Something that could cruise above Soviet air defenses where interceptors couldn't reach. Something that could carry nuclear weapons weighing tens of thousands of pounds across oceans and continents. Boeing won the original contract in 1946, but their early designs kept falling short. Straight-wing propeller configurations couldn't deliver the performance requirement. For 2 years, engineers struggled with impossible demands. Then came that weekend in Dayton. The prototype of their redesigned bomber flew on April 15, 1952. The Air Force ordered mass production before flight testing was even complete. They couldn't wait. The Cold War was heating up, and America needed its nuclear delivery system operational as fast as possible. Between 1952 and 1962, Boeing built 744 B-52s across 8 different variants. Today, only 76 of the final B-52H models remain in service. Every single one was built over 6 decades ago. And every single one traces its existence back to that desperate weekend in an Ohio hotel room. The B-52H entered service in 1961. John F. Kennedy had just become president. The Berlin Wall was under construction. The first human hadn't yet orbited Earth. The youngest B-52 currently flying rolled off Boeing's assembly line that year. 60-plus years later, these same aircraft are still conducting combat missions. Not aircraft of the same model. The same individual aircraft. The same aluminum structures that Boeing workers assembled during the Kennedy administration still carry crews into harm's way today. Grandfathers who flew B-52s during Vietnam could have sat in the same physical cockpit seats their grandsons occupy now. This longevity seems impossible. Modern military aircraft typically serve 20 to 30 years before retirement. Airframes fatigue. Metal stress accumulates. Structures become unsafe for the demands of military operations. Yet the B-52 keeps defying these expectations decade after decade. The secret is understanding what's been replaced and what hasn't. Almost nothing inside today's B-52s matches the original configuration. Engines have been swapped out multiple times across the decade. Avionics systems have been gutted and completely rebuilt. Weapon systems bear no resemblance to the nuclear delivery configuration these bombers originally carried. Cockpit instruments evolved from analog gauges to digital displays. Communication systems, navigation equipment, defensive countermeasures have all been upgraded, replaced, and upgraded again. If you listed every major component of a B-52 and checked whether it matched the 1961 original, you'd find almost nothing in common. The aircraft has been rebuilt from the inside out multiple times over. But one thing remains unchanged. The fundamental airframe. The aluminum skeleton. The swept wings. The distinctive nose profile. The structural bones that give the B-52 its physical shape. This skeleton refuses to quit because Boeing's original engineers didn't trust themselves. Aerospace engineering in the 1950s operated with significant uncertainty. Computer modeling didn't exist. Mathematical predictions had limit. Wind tunnel testing could only reveal so much about how an aircraft would actually perform. Facing these unknowns, Boeing's designers did something that seemed wasteful at the time. They overbuilt everything. Structural margins far exceeded what normal operations would require. Components were rated for stresses that should never occur in actual flight. Joints and connections were designed for lifespans that seemed absurdly long. The engineers added extra strength as insurance against their own potential calculation errors. This paranoid over-engineering accidentally created an immortal airframe. Modern analysis confirms what decades of service have demonstrated. The B-52's structural skeleton has enough remaining life for decades more operations. Metal fatigue hasn't accumulated at dangerous rate. The bones remain strong while everything around them gets replaced generation after generation. The B-52 will keep flying because the one thing that can't be upgraded never needed upgrading in the first place. The B-52's most distinctive feature is its engine configuration. 8 turbofan engines mounted in 4 twin pods beneath the swept wings. No other operational aircraft uses this arrangement. There's a reason for that. It's horribly inefficient. When the B-52 was designed, jet engine technology was primitive. Individual engines didn't produce enough thrust to lift a fully loaded bomber. The solution was simple. Add more engines. 8 engines generating moderate thrust could do what 2 powerful engines couldn't. The original engines were Pratt & Whitney J57 turbojet. They were thirsty, smoky, and unreliable by modern standards. The B-52H upgraded to TF-33 turbofans, which improved efficiency somewhat but still fell far short of contemporary engine performance. Those TF-33 engines are still flying today. They've been in service for over 60 years. Finding replacement parts has become an exercise in archaeological engineering. Some components are manufactured by companies that no longer exist. Others require custom fabrication because original specifications have been lost. The Air Force has been trying to replace these engines for decades. The current plan involves installing 8 new Rolls-Royce F-130 engines, which will dramatically improve fuel efficiency, reduce maintenance requirements, and extend the aircraft's operational range. This re-engining program is expected to cost over $11 billion and take until the 2030s to complete. 8 engines also create 8 times the maintenance burden, 8 times the fuel systems, 8 times the potential failure points. A modern bomber design would never use this configuration. But the B-52 wasn't designed for modern efficiency. It was designed for Cold War survival. And it survived. The B-52's original purpose was singular and terrifying: deliver thermonuclear weapons to the Soviet Union. Everything about the aircraft was optimized for this apocalyptic mission. During the height of the Cold War, B-52s maintained continuous airborne alert. Aircraft loaded with nuclear weapons flew 24-hour missions along routes that would allow immediate strikes on Soviet targets if ordered. This operation, called Chrome Dome, kept nuclear-armed bombers in the air at all times between 1960 and 1968. The logic was grimly simple. Bombers on the ground could be destroyed in a surprise Soviet attack. Bombers already airborne could retaliate even if every American air base was vaporized. The B-52 became the airborne leg of the nuclear triad, alongside ground-based intercontinental ballistic missiles and submarine-launched weapons. Pilots trained endlessly for missions they hoped would never happen. They memorized target coordinates in the Soviet Union. They practiced low-level penetration routes designed to evade radar. They understood that if they ever received authentic launch orders, they probably wouldn't be coming home. Not because they'd be shot down, but because there might be nothing left to come home to. The psychological weight was crushing. These weren't combat missions in any traditional sense. They were one-way tickets to participate in human extinction. Some pilots coped through dark humor. Others through rigid compartmentalization. Many struggled with the implications for the rest of their lives. Chrome Dome ended after 2 accidents involving nuclear weapons. In 1966, a B-52 collided with a refueling tanker over Spain, dropping 4 hydrogen bombs near the village of Palomares. In 1968, another B-52 crashed in Greenland, scattering nuclear material across the ice. Neither incident resulted in nuclear detonation, but both demonstrated the risks of keeping armed bombers constantly airborne. The B-52 remains nuclear capable today. It can carry air-launched cruise missiles equipped with nuclear warhead, but the continuous airborne alert is history. Now nuclear-armed B-52s wait on the ground, ready to launch within minutes if ordered. December 1972. Hanoi, North Vietnam. The most heavily defended airspace in human history. Surface-to-air missile batteries surrounded the capital in overlapping kill zones. Radar systems tracked every approaching aircraft. Gunners waited for the bombers they knew would come. The B-52s came anyway. Operation Linebacker 2 represented the most intense bomber campaign of the Vietnam War. For 11 consecutive days, waves of B-52s penetrated North Vietnamese airspace and struck targets in and around the enemy capital itself. What had been off-limits throughout most of the war became the primary target. Maximum pressure, maximum risk, maximum destruction. The North Vietnamese threw everything they had at the attacking formations. SA-2 missiles streaked upward, their rocket motors burning bright against the night sky. Radar-guided anti-aircraft guns filled the air with explosive shells. Every B-52 flying into that airspace knew the odds weren't good. 15 didn't make it home. 33 crew members died during Linebacker 2. Shot down over enemy territory, their aircraft burning, their options exhausted. Another 33 managed to eject successfully, only to parachute into captivity. North Vietnamese soldiers captured them, and some would spend years in prison camps before finally being released. These losses shook the Air Force to its core. The B-52 had been designed as an invincible nuclear delivery system, capable of penetrating any defense to deliver its apocalyptic payload. Vietnam proved that even the mightiest bomber could bleed. But the campaign achieved what years of lower-intensity bombing had not. North Vietnam returned to peace negotiations. The political objective was met, even if the cost was staggering. This bloody climax came after 7 years of continuous B-52 operations in Southeast Asia. Operation Arclight had begun back in June 1965, transforming the nuclear bomber into a conventional weapons platform. The concept was brutally simple. Fill the payload capacity designed for thermonuclear weapons with conventional high-explosive bombs instead. Use the aircraft's ability to carry 70,000 pounds of ordnance for jungle warfare rather than civilization-ending strike. The results had been devastating throughout those 7 years. A formation of B-52s dropping full bomb loads could obliterate everything within a zone roughly 2 miles long and half a mile wide. The Vietnamese called these attacks "whispering death," because the bombers flew too high to be seen or heard before their weapons arrived. Terror from an invisible source. By war's end, B-52s had flown over 126,000 sorties in Southeast Asia. The Air Force dropped more bomb tonnage on Vietnam than it had during all of World War II. More explosives than defeating 2 major industrial powers required. All of it concentrated on one small country that refused to surrender. Yet the United States ultimately withdrew without achieving its strategic objective. The destruction was real. The effort was unprecedented. The enemy simply absorbed the punishment and kept fighting. Linebacker 2 worked in the short term. Peace negotiations resumed. Prisoners eventually came home. But the larger questions about strategic bombing effectiveness remained unanswered. Vietnam proved that the B-52 could devastate any target it could reach. It also proved that devastation alone couldn't guarantee victory. The losses sustained during those 11 December days haunted the bomber community for decades. The aircraft designed to win nuclear wars by delivering unstoppable destruction had proven stoppable after all. Modern air defenses could kill B-52s in numbers that mattered. This lesson would reshape how the Air Force employed its bombers in every conflict that followed. Never again would B-52s fly into heavily defended airspace without massive support from other aircraft. Never again would the bomber be treated as invincible. Vietnam had proven otherwise. 20 years after Vietnam, the B-52 returned to combat over Iraq. Operation Desert Storm in 1991 showcased how dramatically the bomber's role had evolved. Gone were the massive formation raids against area targets. The new B-52 missions emphasized precision and psychological impact. Bombers carrying cruise missiles could strike targets from hundreds of miles away, never entering Iraqi airspace. Aircraft that did penetrate enemy territory used updated defensive systems to survive threats that would have destroyed their predecessors. The most famous B-52 mission of the Gulf War was also the longest combat sortie in history at that time. 7 B-52s launched from Barksdale Air Force Base in Louisiana, flew directly to Iraq, launched cruise missiles against priority targets, and returned home. The round trip covered 14,000 miles and took 35 hours. Pilots were in the air for a day and a half straight. This mission demonstrated something important. The B-52 didn't need to be stealthy or fast. It just needed to launch weapons from beyond the reach of enemy defenses. The bomber had evolved from a penetrating nuclear delivery system into a standoff missile truck. Iraqi troops learned to fear the sound of approaching B-52s. The psychological impact of carpet bombing hadn't diminished since Vietnam. Entire units surrendered after B-52 strikes, their defensive positions transformed into moonscapes of overlapping craters. Aircrews have called the B-52 the Buff for decades. Officially, this stands for Big Ugly Fat Fellow. Unofficially, the F stands for something else that better reflects how crews actually talk. The nickname captures something essential about the aircraft. The B-52 isn't elegant. It doesn't look like a modern stealth bomber with its sleek angles and radar-absorbing surfaces. It's a blunt instrument, all wings and engines and bomb bay, designed in an era when brute force mattered more than subtlety. But there's affection in that nickname. Crews who fly the Buff tend to love it, despite or perhaps because of its quirks. The aircraft has personality in ways that newer bombers don't. Its analog origins mean that pilots actually fly the plane rather than managing computer systems. The physical controls, the engine noise, the sheer presence of the thing creates a connection that glass cockpits can't replicate. Every B-52 has a story. These airframes have been flying longer than most pilots have been alive. They've been through multiple wars, countless upgrades, and enough training missions to circle the globe thousands of times. The maintenance logs read like novels, documenting decades of repairs, modifications, and close calls. Some aircraft carry artwork dating back to the Vietnam era. Others have been repainted so many times that archaeologists could probably date the layers like tree rings. Each one is unique, with handling quirks that experienced pilots learn to recognize. The B-52 isn't just an aircraft. It's an institution with wings. 5 people operate the most destructive non-nuclear weapons platform in American military history. Understanding the B-52's specifications starts with understanding what those 5 crew members experience. The aircraft commander and pilot sit side by side on the upper flight deck, surrounded by controls that have evolved dramatically since the 1960s while fundamental flight characteristics haven't. They're managing an aircraft that weighs 185,000 pounds empty and can reach 488,000 pounds fully loaded with fuel and weapons. Getting that mass airborne requires all 8 engines producing their maximum 17,000 pounds of thrust each. The cockpit sits remarkably high above the ground. Pilots look down at ground crews from roughly the height of a 3-story building. The nose stretches so far forward that taxiing requires unusual technique. The wings extend 185 feet from tip to tip, forcing constant awareness of obstacles that might be invisible from the cockpit. Once airborne, the aircraft climbs toward its service ceiling of 50,000 feet. At that altitude, the sky darkens toward black. The curvature of Earth becomes visible on the horizon. The aircraft operates in an environment closer to space than to the surface where humans normally live. Maximum speed reaches only 650 miles per hour, Mach 0.86 at altitude. This feels paradoxically slow given the distances involved. Combat radius extends 4,480 miles without refueling. Missions regularly last 10 to 12 hours. Some extend past 20 hours. The crew experiences time differently than fighter pilots who measure missions in minutes rather than days. Downstairs in a separate compartment, physically isolated from the pilots, the radar navigator and navigator work in an environment dominated by screens and displays. They can't see outside. They experience the mission through data rather than windows. The radar navigator manages weapons delivery, coordinating the release of up to 60,000 pounds of ordnance that the aircraft can carry. The navigator plots courses across 8,800 miles of potential range, calculating fuel consumption, timing, and routes that avoid known threat. The electronic warfare officer monitors the electromagnetic environment, listening for the signals that indicate enemy radar tracking the aircraft. When threats appear, defensive systems respond. Chaff dispensers release metallic clouds to confuse radar. Jammers broadcast signals designed to blind enemy tracking systems. The EWO's world is invisible warfare conducted through frequencies and wavelength. Earlier B-52 variants included a 6th crew member, a tail gunner isolated in the extreme rear of the aircraft. That position has been eliminated. The tail guns have been removed. Modern defense relies on not being targeted rather than shooting back. The physical demands of operating the B-52 differ dramatically from other combat aircraft. Fighter pilots experience brief bursts of extreme stress during missions lasting an hour or 2. B-52 crews experience sustained moderate stress across missions lasting half a day or more. Fatigue management becomes critical. The aircraft has no bunks, no comfortable rest areas. Crew members must remain functional across time spans that challenge human endurance. The internal bomb bay measures roughly 28 feet long and can carry 70,000 pounds of weapons. External hardpoints add another 50,000 pounds of capacity. When fully loaded, the aircraft handles differently than when light. Fuel consumption changes flight characteristics as tanks empty. Releasing weapons alters balance and performance. The pilots must constantly adapt to an aircraft that transforms throughout the mission. The bomber's 159-foot length and 40-plus foot height create a physical presence that dominates any environment. Ground operations require specialized equipment. Maintenance demands access platforms and lifts capable of reaching components 3 stories above the ground. Every aspect of supporting the B-52 must accommodate its sheer size. These specifications translate into crew experiences unlike any other in military aviation. The scale of the aircraft, the duration of the missions, the payload being delivered, the isolation of different crew positions, all combine to create an operational environment that bomber crews describe as simultaneously boring and terrifying. Hours of routine flying punctuated by minutes of maximum intensity when weapons are delivered. 5 people. 1 aircraft, 60,000 pounds of ordnance, ranges measured in thousands of miles, missions measured in half-days. This is what the B-52's specifications actually mean in human terms. The B-52's weapons capability has expanded dramatically from its original nuclear-only mission. Modern aircraft can carry virtually every air-delivered weapon in the American arsenal. Gravity bombs range from 500-pound general-purpose munitions to 2,000-pound penetrators designed to destroy hardened bunkers. The aircraft can carry cluster munitions that scatter smaller bomblets across wide areas. Precision-guided bombs using GPS or laser guidance have largely replaced unguided ordnance for most missions. The AGM-86 air-launched cruise missile gives the B-52 true standoff capability. These missiles can be launched from hundreds of miles away, navigating to their targets using terrain-following radar and GPS. The conventional version carries a 3,000-pound warhead. The nuclear version remains classified but is believed to carry a variable-yield thermonuclear weapon. AGM-158 Joint Air-to-Surface Standoff missiles represent the newest cruise missile capability. These stealthy weapons can strike targets over 600 miles away with precision measured in feet rather than yard. The extended-range version pushes that distance to over 1,000 miles. For maritime missions, the B-52 can carry AGM-84 Harpoon anti-ship missiles. More recently, the aircraft has been adapted to carry the AGM-158C long-range anti-ship missile, which can engage naval targets at ranges exceeding 200 miles. This capability transforms the bomber into a ship killer, threatening enemy fleets from distances they cannot effectively counter. Mines represent another mission set. The B-52 can rapidly deploy naval mines across sea lanes, closing waterways to enemy shipping. During the Vietnam War, B-52s mined North Vietnamese harbors as part of Operation Pocket Money, demonstrating how the bomber could influence naval warfare without ever engaging ships directly. The common theme across all these weapons is range. The B-52 doesn't need to get close to its target. It launches from distances that keep it safe from most air defense systems, letting the weapons do the dangerous work of penetrating enemy airspace. A 70-year-old bomber flying against modern air defenses sounds suicidal. The B-52 survives through electronic warfare systems that have evolved continuously since the aircraft entered service. The AN/YELQ-172 electronic countermeasures system can jam enemy radar, preventing targeting by surface-to-air missiles or enemy fighters. The system detects incoming radar signals, analyzes their characteristics, and broadcasts jamming signals tailored to confuse specific threat type. Chaff dispensers release clouds of metallic strips that create false radar returns. Flare dispensers eject burning countermeasures designed to lure heat-seeking missiles away from the aircraft's engines. These systems can be activated manually by the electronic warfare officer or automatically in response to detected threat. The AN/ALR-46 radar warning receiver alerts crews when enemy radar is tracking them. Different tones indicate different threat types and levels of danger. Pilots and electronic warfare officers learn to interpret these audio cues instantly, responding with appropriate countermeasures before enemy weapons can be launched. Newer systems include the AN/WW2 Advanced Electronic Warfare Suite, which integrates multiple countermeasure systems into a coordinated defensive package. This upgrade reflects decades of lessons learned about what actually works against modern air defenses. But the B-52's primary defense isn't electronic. It's tactical. Modern B-52 missions keep the aircraft well away from enemy air defense systems. Standoff weapons launch from hundreds of miles away. Flight routes are planned to avoid known threat locations. The bomber operates in environments where air superiority has already been established by fighter aircraft and suppression of enemy air defense missions. When the B-52 can't avoid threats entirely, it relies on support. Fighter escorts, electronic warfare aircraft, and anti-radar missiles clear the path. The bomber rarely operates alone in contested airspace. Flying a B-52 is unlike any other experience in military aviation. Missions routinely last 10 to 12 hours. Some extend to 20 hours or more. Crew members must manage fatigue, maintain focus, and remain ready for action during flights longer than most people stay awake. The aircraft has limited provisions for rest. There's no bunk, no comfortable seating. Just 5 crew stations in a noisy, vibrating aluminum tube. The cockpit sits remarkably high above the ground, giving pilots an unusual perspective during taxi and takeoff. The nose gear is so far forward that the aircraft seems to balance precariously on its main landing gear. This configuration requires unusual landing technique. Pilots must manage crosswinds carefully to avoid dragging the wing-mounted outrigger gear. Those outrigger gears, small wheels mounted near the wingtips, exist because the wings flex so dramatically during flight. On the ground, they prevent the wingtips from scraping the runway. In the air, the wings can flex upward by several feet under full fuel load. First-time passengers often panic watching the wings bend, assuming something is breaking. Experienced crews barely notice. Communication between crew stations relies on the intercom system. The 5 crew members can speak to each other, coordinate actions, and share information without radio transmissions that enemy forces might intercept. Building crew coordination takes months of training. Effective B-52 crews function as single organisms, anticipating each other's actions without conscious thought. The navigator and radar navigator work in a downstairs compartment, physically separated from the pilot. They manage weapons delivery, terrain avoidance, and much of the mission planning that occurs in flight. This separation creates unique challenges. The pilots can't see what the navigators are doing. The navigators can't see out the windows. Trust becomes essential. Of the 744 B-52s built, only 76 remain in active service. Where did the rest go? Most went to Davis-Monthan Air Force Base in Arizona, where the Aerospace Maintenance and Regeneration Group maintains the world's largest aircraft boneyard. Rows of decommissioned B-52s bake in the desert sun, their aluminum slowly oxidizing in the dry climate that preserves them better than any other environment. Under arms control treaties with Russia, many B-52s were destroyed in ways that could be verified by satellite. Aircraft were cut into pieces using enormous guillotines. Wings separated from fuselages. Fuselages sliced into sections. The destruction was photographed and transmitted to Soviet observers as proof that America was complying with treaty obligations. These images became iconic representations of arms control in action. Massive bombers that once threatened nuclear annihilation reduced to aluminum scrap by their own country in the name of peace. But the boneyard isn't just a graveyard. It's also a parts warehouse. When operational B-52s need components that are no longer manufactured, maintenance crews turn to the stored aircraft. Wings, engines, landing gear, avionics boxes, wiring harnesses, anything usable gets stripped from the decommissioned bombers and installed in flying aircraft. This cannibalization has kept the B-52 fleet operational long past when parts availability should have grounded it. Some components in flying aircraft might have originally been installed in bombers that were retired decades ago. The planes stay alive by consuming their dead. Right now, the B-52 fleet is undergoing the most comprehensive upgrade program in its history. 4 simultaneous modernization efforts will transform these 60-year-old bombers into platforms more capable than at any previous point in their existence. The first transformation involves radar. The current APQ-166 system dates back to technology that seems primitive by modern standard. Its replacement, an active electronically scanned array radar, represents a generational leap in capability. Ground mapping will improve dramatically, allowing crews to identify and target objects that current systems can't resolve. Weather detection becomes more precise. Multiple targets can be tracked simultaneously. Electronic beam steering replaces mechanical scanning, eliminating moving parts that wear out and fail. The second transformation addresses engines. Those 8 TF-33 turbofans have been pushing B-52s through the sky since the 1960s. Finding replacement parts has become an exercise in industrial archaeology. Some components come from manufacturers that no longer exist. Others require custom fabrication from specifications that were documented on paper systems nobody uses anymore. New Rolls-Royce F-130 engines will change everything. Fuel efficiency improves by up to 40%, dramatically extending range and reducing the tanker support that current operations require. Maintenance demands drop significantly, improving availability rates and reducing operating costs. The program price tag exceeds $11 billion and the work extends into the 2030s. But the result will be aircraft that can fly further, longer, and cheaper than ever before. The third transformation involves weapons. Hypersonic missiles traveling faster than Mach 5 are entering the American arsenal. These weapons can strike targets before enemies can react, traveling at speeds that current air defenses cannot counter. The B-52 will carry them. Integrating hypersonic weapons requires extensive modifications. The internal weapons bay needs new mounting systems. The rotary launcher that has served for decades must be replaced with hardware designed for these revolutionary munitions. Software updates must teach aircraft systems how to communicate with weapons that operate on entirely different principles than conventional bombs and missiles. The fourth transformation upgrades communications. Future warfare will be networked in ways that current systems can't support. Information will flow constantly between aircraft, drones, satellites, ships, and ground controllers. Bandwidth requirements exceed anything the B-52 was designed to handle. Protocols that didn't exist when these bombers were built must be integrated into avionics that are themselves upgrades of previous upgrade. These 4 programs represent the culmination of 6 decades of continuous improvement. The B-52 flying today would already be unrecognizable to its original 1960s crews. Where analog gauges once filled instrument panels, digital displays now present information in formats that couldn't have been imagined. Where navigators once plotted courses using celestial observations and dead reckoning, GPS systems pinpoint position within meters. Where bombing computers required manual calculations, digital processors manage weapons delivery with precision measured in feet. The offensive avionics upgrade in the 1980s first transformed the B-52 from carpet bomber to precision striker. Digital systems replaced analog computers. Targeting that once meant hitting a general area became targeting specific buildings. The same airframe designed to destroy cities could suddenly destroy individual rooms. GPS navigation eliminated techniques that dated back to ancient mariners. Data link systems connected isolated bombers to vast military network. Communication upgrades integrated the aircraft into information environments that its designers couldn't have conceived. Each decade brought new capabilities layered onto previous improvements. Each upgrade built upon foundations laid by earlier modifications. The cumulative effect has been constant transformation while the fundamental airframe remains unchanged. When current modernization programs complete, probably sometime in the 2030s, only the aluminum skeleton will remain from the original aircraft. The wings, the fuselage, the basic structure that Boeing built over 60 years ago. Everything else will be new. Newer, in many cases, than systems on aircraft designed in the 21st century. The B-52 won't just remain relevant. It will be more capable than at any previous moment in its 7-decade existence. Ancient bones. Cutting edge everything else. The combination seems impossible until you realize it's been happening continuously since the 1960s. This is simply the latest chapter in an upgrade story that never ends. The Air Force has been trying to replace the B-52 for over 50 years. Every attempt has failed. The B-1 Lancer was supposed to be the successor. This supersonic bomber featured variable sweep wings, advanced avionics, and low-altitude penetration capability that would allow it to sneak beneath Soviet radar. President Carter canceled the program in 1977, arguing that cruise missiles made manned bombers obsolete. President Reagan revived it in 1981. The B-1 finally entered service in 1986. But the B-1 never replaced the B-52. It supplemented the fleet without making the older bomber obsolete. The B-1's mechanical complexity created maintenance nightmares. Its operating costs exceeded projections. The aircraft that was supposed to be cheaper and more capable turned out to be expensive and problematic. Today, the B-1 fleet is being retired while the B-52 keeps flying. The B-2 Spirit was the next attempt at replacement. This flying-wing stealth bomber can penetrate the most advanced air defenses on Earth without being detected. It's a technological marvel. It's also spectacularly expensive. Only 21 were built, at a cost of over $2 billion each. The Air Force wanted 132. Budget reality intervened. The B-2 performs missions the B-52 cannot, penetrating defended airspace to strike high-value targets. But there aren't enough B-2s to replace the B-52's capacity for delivering massive amounts of ordnance. The stealth bomber handles surgical strike. The Buff handles sledgehammer blows. The B-21 Raider is the newest attempt. This stealth bomber is currently entering production, with the Air Force planning to acquire at least 100 aircraft. It will eventually replace the B-2 and the B-1, but not the B-52. Current plans keep the Buff operational alongside the B-21 through at least 2050. The Air Force has apparently concluded that the B-52 fills a role that no other aircraft can match cost-effectively. It's not glamorous. It's not stealthy. It's not fast. It's just irreplaceable. Afghanistan, Iraq, Syria, Libya. 4 countries across 2 continents. 2 decades of continuous combat. 1 aircraft that fought in all of them. The B-52's war on terror began immediately after September 11, 2001 and didn't end until American forces withdrew from Afghanistan 20 years later. Throughout that entire period, the Cold War bomber remained deployed, adapted, and engaged. Afghanistan came first. The same aircraft built to destroy Soviet cities provided close air support for Special Forces operators hunting Taliban and Al-Qaeda fighters in mountain terrain. Bombers cruising at 50,000 feet dropped precision munitions guided by ground controllers with laser designators. Weapons struck within meters of aim points, close enough to support troops in contact without unacceptable friendly fire risk. The psychological impact proved equally valuable. Taliban fighters learned to recognize B-52 contrails. The sound of distant engines at high altitude meant destruction was coming. Sometimes bombers flew over enemy positions without dropping ordnance. The fear alone disrupted operations. Iraq followed in 2003. Shock and awe included B-52 strikes against military installations throughout the country. The invasion phase gave way to years of counterinsurgency operations where bombers supported ground forces fighting insurgent groups in environments the aircraft was never designed for. Syria and Iraq merged into a single theater when ISIS emerged. B-52s operated from Al Udeid Air Base in Qatar, striking targets across both countries. The bomber's loiter capability made it ideal for dynamic targeting where opportunities appeared suddenly and required immediate response. An aircraft could remain on station for hours, waiting for intelligence to develop, then strike within minutes of target identification. Libya represented a different mission set entirely. In 2011, B-52s launched cruise missiles against Gaddafi's air defense systems. The bomber never entered Libyan airspace. It didn't need to. Standoff weapons traveled hundreds of miles to destroy radar installations and missile batteries, helping establish no-fly zones that contributed to the regime's eventual collapse. 4 countries, multiple mission types, nuclear bomber performing close air support, strategic aircraft conducting counter-terrorism strike, cruise missile truck enabling regime change operations. The B-52 adapted to whatever 21st-century warfare demanded because its fundamental characteristics, range, payload, endurance, precision through modern upgrades, translated into flexibility that couldn't be matched by aircraft designed for narrower purposes. As American strategic focus shifts toward potential conflict with China, the B-52 is once again adapting to new requirements. The Pacific Ocean presents unique challenges for air power. Distances are vast. Bases are scattered across islands separated by thousands of miles of water. China's anti-access capabilities threaten aircraft carriers and forward bases that American forces have relied upon for decades. The B-52's range becomes crucial in this environment. Bombers can operate from bases in Guam, Australia, or even the continental United States, striking targets across the western Pacific without needing vulnerable forward positions. Air refueling extends this reach even further. New anti-ship missiles transform the B-52 into a maritime strike platform. A single bomber carrying long-range anti-ship missiles can threaten enemy naval formations at distances exceeding 500 miles. A formation of B-52s could saturate Chinese naval defenses with more missiles than they could effectively counter. Bomber task forces have begun deploying to the Pacific more frequently. These rotational deployments demonstrate American capability and commitment while providing aircrews with experience operating in the theater where they might one day fight. The irony is thick. The B-52 was designed to fly from America to bomb Russia. It spent its combat career striking targets in Southeast Asia, the Middle East, and Central Asia. Now it's preparing for potential conflict in the same Pacific region where American forces fought during World War II. The bomber designed for one war has now served through 3 generations of conflict without ever performing its original mission. The B-52's next evolution involves weapons that didn't exist when the aircraft was designed. Hypersonic missiles, traveling at speeds exceeding Mach 5, represent the cutting edge of military technology, and the B-52 will carry them. The AGM-183 air-launched rapid response weapon was intended to be the first operational hypersonic missile carried by the B-52. Testing challenges have delayed the program, but development continues. When operational, this weapon will allow the bomber to strike targets at distances and speeds that current air defenses cannot counter. The rationale for using a 70-year-old bomber to carry next-generation weapons seems counterintuitive, but it makes perfect sense when you understand the economics. Developing a new aircraft to carry hypersonic missiles would cost billions and take over a decade. The B-52 already exists. Its payload capacity can accommodate the new weapons. Its range can deliver those weapons to launch points within striking distance of any target on Earth. Why build something new when something old works perfectly well? The combination of ancient airframe and futuristic weapon captures everything about the B-52's impossible longevity. The plane itself is almost irrelevant. What matters is getting weapons to where they need to be launched. The B-52 does that job as well as any aircraft ever built. Future upgrades will likely continue this pattern. Whatever new weapons America develops, the B-52 will probably carry them. The airframe has become a permanent feature of American air power, adapting to whatever the future requires. Nobody pretends the B-52 is cheap to operate. The Air Force acknowledges the costs openly. The controversies aren't hidden. The decision to keep flying these aircraft represents a calculated choice, not ignorance of the problems. Truth number 1. Parts don't exist anymore. Components common in the 1960s haven't been manufactured in decades. The companies that built them closed. Factories were demolished. Tooling was destroyed. Engineers with institutional knowledge retired or died. Technical documentation exists in formats that modern systems can't process. Maintenance crews hunt through warehouses of decommissioned aircraft for surviving spares. They fabricate replacements from scratch. They reverse engineer parts from physical examples when specifications have been lost. Every workaround costs more than mass production would. Truth number 2. Fuel consumption is terrible. Those 8 TF-33 engines date to the 1960s. They burn fuel at rates that modern engines would cut dramatically. Every B-52 mission costs more than equivalent missions by efficient aircraft. The waste accumulates across thousands of annual sorties. Truth number 3. Environmental standards can't be met. The engines produce emissions that would never be acceptable in new aircraft designs. Hydraulic fluids and lubricants include compounds now recognized as harmful. Modernization addresses some concerns, but these aircraft will never be as clean as purpose-built replacements. Truth number 4. Opportunity costs are real. Every $1 billion spent on B-52 upgrades is $1 billion not spent on next-generation development. The $11 billion engine replacement program could theoretically fund significant work on new platforms. Critics argue these investments lock the Air Force into obsolete technology. Truth number 5. The alternatives cost even more. This is the uncomfortable truth that ends every debate. Replacing the B-52 with new-build aircraft would cost tens of billions beyond current upgrade programs. Development timelines stretch across decades. Testing and certification add more years. No proposed replacement has ever passed the economic test. The B-1 was supposed to replace the B-52. It didn't. The B-1 is now being retired while the B-52 continues flying. The B-2 was the next attempt. Only 21 were built because costs exceeded projections. The B-21 is entering production, and it still won't replace the B-52. The bomber keeps flying because commanders have done the math repeatedly and reached the same conclusion every time. The costs of maintaining the B-52 are high. The costs of replacing it are higher. That's not a celebration. It's a calculation. The aircraft continues because the alternatives are worse. The B-52 Stratofortress will celebrate its 100th birthday in service. Let that sink in. An aircraft designed during the Truman administration will still be flying combat missions when children born today have grandchildren of their own. No one planned for this. The original designers expected the B-52 to serve maybe 20 years before replacement. The Air Force expected successive generations of bombers to make the buff obsolete. Defense planners expected nuclear deterrence to evolve beyond manned aircraft entirely. Instead, the B-52 became something that military aviation has never seen before or since. An aircraft so perfectly suited to its role that nothing else could replace it. A platform so adaptable that it outlived its own obsolescence. A weapon system so cost-effective that newer alternatives couldn't compete. The bomber has dropped more ordnance on America's enemies than any other aircraft in history. It has served in every major conflict since the Korean War. It has evolved from nuclear apocalypse machine to precision strike platform to cruise missile truck to potential hypersonic weapon carrier. Each transformation seemed impossible until it happened. There's a lesson here about military technology that the Pentagon has learned and relearned across 7 decades. The best weapon isn't always the newest or the most advanced. Sometimes it's the one that works, that's available, that can do the job today rather than promising to do it better someday. The B-52 does the job. It has always done the job. It will continue doing the job until someone finally builds something that does it better. So far, no one has.